Okay, here we're going to find a little arc length. Now, we can develop a formula in polar coordinates so that we can find arc length for graphs given in polar coordinates. But what, what it stems from is taking this parametric set of equations, using this to develop, in other words, if we're starting with a curve, r equals f of theta, then we can have this, and y is r sine, r f of theta, sine theta. Okay, that's a little sloppy. Fix that. F of theta, sine theta. Okay, and we saw that this would give us in our with this choice as parametric form, we ended up with this. We wanted dx d theta squared plus dy d theta squared d theta. Now, if we are working with polar coordinates, we can make a transition here to get a little bit different formula. Remember, this one was for arc length given that parametric form. Okay, we can pick it up over here now. As I was saying, this is a parametric form. Now, this isn't bad if we didn't have this product in here, but if we just had a function, a simple function of t or theta, but we got f theta cosine theta, f theta sine theta. So we're going to do a little bit of simplification and see if we can get this thing simplified a little bit. I mean, it'd be okay to use this form, but we're going to see that we might be able to get that to look a little nicer here. But notice what I'm drawing here. I'm going to have a big quantity in here. Cause I got my two derivatives, these two, and now I got to square them. So I have f prime cosine theta minus f sine theta, and you got to square that. And then you have f prime sine theta plus f cosine theta, and you got to square that quantity. So let's go ahead and do that. And I'll leave myself a little bit of room here. Got f prime cosine theta. We'll just write it like this, squared minus 2 f prime f cosine theta sine theta plus f sine theta. I'm going to square that. Plus, we got f sine f prime sine theta squared. And we got plus 2 f prime sine theta cosine theta. And then plus an f cosine theta quantity squared like that. Okay, so then you notice a couple things happen here. If you notice, you can have f prime cosine squared, and you can have f prime sine squared over here being added. So that's just an f prime squared. Okay, sine squared cosine squared is 1. Then you also have f sine squared and f cosine squared. That will just reduce to an f squared. These two terms, this one and this one, are opposites, so they're gone. So I don't need all of that. Okay, took the whole thing off of there. And this is the form that we're going to use. Now I'm going to clean that up a little bit. Our surface area, arc length. Shrink that down. be this alpha to beta square root. We'll make it f of theta squared plus f prime of theta squared d theta. So that's kind of nice. You could say r and r prime if you want to. But now these are derivatives with respect to theta. Okay, so we haven't seen the use for that directly before, but we are seeing it here, f prime of theta. Okay, all right, now let's try an example. Let's see. This is example 5. It's on the paper. So let's see. Example 5, we have curve. We have the r equals 1 plus sine theta curve again. And let's take a look at this. They want the arc length for this whole portion here. Okay, 0 to 2 pi. So you need a little picture of that here. This one we've been working with for a while. A few examples now. We know it looks like this. And we need to integrate, and I don't want to integrate through this cusp. This can be on the endpoint of our integral, of our interval, but we don't want to go right through it. Things can go wrong when that happens because the derivative doesn't exist right there. Okay, so we can have that on an endpoint, but not in the middle. So we'll get around that just by noting that this point down here actually corresponds to theta equals negative pi over 2. That's the point here. So you can find that if you just set up a small table with your function here. If theta is negative pi over 2, I get a 0 here. Okay, and then the reason I chose that is because now I'm going to integrate straight up this way, coming along this direction. Okay, all along here, and stop at pi over 2, in which case you see r equals 2. Okay, so now if I get that and I double it, I'll have my answer. So I'm going to take double negative pi over 2 to pi over 2, and now I need the square root. I need this quantity squared, and I need the derivative squared, so I need cosine squared. Okay, now let's see where this leads us. I'm going to write this as alpha and beta again, just to save a little writing. This will be 1 plus 2 sine theta plus a sine squared theta and a cosine squared theta, d theta. So that's 2 plus 2 sine. So you've got a 2 root 2 alpha to beta. And inside here you have a 1 plus sine theta. Okay, now that is not something that we can integrate directly. We're going to have to work on that. I'm going to try something here. Okay, I'm going to try something. Okay, we are, let's see. Yeah, okay, so here's an integral. And it doesn't appear to be an easy way to get that. Okay, so I was just thinking about this, trying this. So alpha to beta. What if we did this? 1 plus sine theta, 1 minus sine theta, like that. You know, that's a standard technique to try to clear out radicals. So we might try that. And that would give us a 1 minus sine squared up top and down here. We just had that 1 minus sine theta. But that's 2 pi, 2 or 2 alpha beta. We have the cosine up there. And I'm going to write this as 1 minus sine theta with a negative half. And now we can see what's in front of us. We've got a u to the n du form here. So here's the u, 1 minus sine theta. Du is opposite of cosine theta. So we just need a negative. So we'll have a minus 2 over 2. And we'll have a 1 minus sine theta to the 1 half. And then because you'll have a 2 out here because of that. And you're going to go from minus pi over 2 to pi over 2. So we're able to get around that problem, luckily. So we got a minus 4 root 2, and then in here we have 1 minus sine pi over 2. Okay, to the half, and then minus 1 minus sine negative pi over 2 to the half. So let's see. This is 0, and this is the sine of negative pi over 2. This is negative 1. Negative 1 is a 2, so that's minus 2 to the half, so minus root 2. And that ends up giving us, what is it, an 8. 4 times 2 is 8. Okay, so that one worked out okay.